All right, hello. We are going to be looking at 6.3, which is going to be adding and subtracting polynomials. So we're going to take what we learned, not last semester, but the last couple classes about combining like terms, and you have worked on this before. We're going to take this idea of combining like terms, and we are going to work with adding groups of like terms and subtracting groups. And when we're able to do a problem like this where we can find the difference, so where there's subtraction, you, by the end of this video, will be able to simplify that expression. So just a quick vocab review, a monomial. So if I say a monomial, I'm referring to a number, a variable, or a product of numbers and variables. So like a number being like 7, a variable being like x. So here's a number, a variable, or a product of numbers and variables. So 3x squared actually means 3 times x times x, if I were to expand that out. That's what that would look like. It is a product, which is multiplication, of numbers and variables. So we can have multiple variables multiplying, we can have just a single number. So 3x squared, which is this expanded out. Now it would be very inconvenient to have to write that expanded out all the time. But 3x squared is a monomial. So that is just a term. A polynomial is when there is more than one monomial and it's either added or subtracted together. So here's our example down here. And in standard form, we write it in what's called descending order, where we have our largest exponent down to our constant term, which is just our regular number. So here is a polynomial. There are 3 terms, 1, 2, 3. They are separated by plus signs. So that's kind of how we know where or which terms there are. They're separated by the plus signs here. May also be separated by minus signs. So when we're adding polynomials, we are going to combine like terms, and that's what we've been practicing. So we're just going to look for everything that's a like term, and there are lots of different strategies you can use for this. But here's kind of what we're looking for first. There are 2 groups here. There are 2 groups of polynomials, and I need to make sure that it says plus in between them. So really what I'm saying is I'm going to take this whole group and I'm just adding it to this whole group. I'm going to add them together. I'm just going to count them up. So when we have just addition like that, what we're able to do is we can rewrite this without the parentheses, and that's really how you've been used to seeing it in class. So here's what I'm going to do. I'm going to work from left to right, and I'm going to rewrite in order. So I'm going to create some categories. I have x to the third. That is my largest x value. There's no other x. There's no x to the fourth, x to the fifth. X to the third is my largest x value. So I'm going to create an x to the third category. I'm going to have an x to the second category, x to the first, and a regular number category. And now I'm just going to go through and I'm going to put all of my numbers in the category, or each term in the category where it belongs. So I'm going to do that in purple for my first. 5x to the third is going to go in the x to the third category. So 5. And then I can cross that out. Negative 4x squared. Remember, the sign that's in front stays attached. So if you wanted to write positive 5, this is negative 4x to the second. This is positive x, so I use that one, and negative 9. So that one I just kind of had to go down the line. Plus, here's my next row. I have a negative 3. So negative 3 is going to go in my regular number category. Actually, let me use a different color. I'll use orange, kind of lakery. So negative 3 is going to go in my regular number category. Positive 6x to the second goes there. Negative 7x is going to go in my x category, and negative 2x to the third goes in that category. So I've taken all of my terms and I line them up in their correct category. And now what I'm going to do is just combine them using my sign rules. So down below here, I'm going to write what I get for each one of these when I follow my sign rules. So positive 5 minus 2. 5 minus 2 is 3. So I have a total of 3x to the thirds. Negative 4 plus 6. Signs are different, so I'll subtract and get positive 2x to the seconds. For my x, I have 1x and negative 7x, which will give me negative 6x. And for my constant terms, a negative 9 and a negative 3 add to make negative 12. And so this is what we've been doing with combining like terms. So when we're adding polynomials, really the only difference between combining like terms and adding polynomials is that we're working with groups, and we have to pay attention to make sure that that's a plus sign. If it's a plus sign, then we're just adding one group to the other, and there's no other work. So here's what I'm going to do. I'm going to take a look. I have x to the third. Seems to be my largest exponent. So I'm just looking across the top here and I see a 3. I see another 3 here. Nothing bigger than that. So I'm going to be working with x to the third, x to the second, x to the first, and regular numbers. And I just kind of work my way across. And really, if you really wanted to, I have negative 8x to the third. So I'm just going to write a negative 8 in here, because it's in the x to the third category. At the end, I'll put it back on. So this is another strategy. If you think you'll forget to add that x to the third back on, then don't leave it off. Negative 12x, so that's a negative 12, goes in the x category. Positive 9 is a regular number, so that goes in that category. 5x to the third, that is a x to the third, so that's going to go here, a positive 5. X to the second is 1, so that's a 1x to the second. Negative 8x, and a positive 1. So if it helps you without having to see all the other variables, if you just want to write what's called the coefficients, the numbers, just remember to write your variables back down in your answer. So I'm going to show you here in blue. Negative 8 plus 5 is negative 3, and that was an x to the third. 1 is not being changed by anything, so it's still just positive 1x to the second. Negative 12 and negative 8 combine to make negative 20, and that has an x attached to it. And then these are the only ones that I don't have to worry about writing a variable, and that's 9 plus 1, which is a positive 10. So there's another way of doing that. So when we have a plus sign, no big deal. When we have a minus sign, a minus in between, there is a little bit of a different rule, and then we go back to doing the same thing that we did with adding. So here's the different rule, is we have to distribute the negative to everything inside the parentheses that the negative is attached to. So this negative is attached to everything over here. It is not attached over here. So this negative is affecting all of these things. So I'm going to distribute that negative in. And we've practiced this in 6.2, but a negative just means the opposite of. So the opposite of negative 2x squared is positive 2x squared. The opposite of a positive 7x is a negative 7x. And the opposite of a positive 11 is a negative 11. So all I've done was I took this negative and I distributed the negative in, and it just changed the signs. That's all that negative does. So now that I've changed those signs, I'm not working with this equation anymore. This is my new group down here. And I don't have to worry about this negative because I already used it up. So now I'll highlight what we're using. We're going to use all of this, and we're adding it or combining it to this. So now I'm going to do the same thing I did in my other example when we were adding. I'm going to look for my largest exponent. I have x to the second. And I'm going to work all my way down there, x to the first and regular numbers. So those are the three categories that I should have here. So I have a negative 10 x to the second. I have a positive 4x and a negative 3. I also have a positive 2x to the second, a negative 7x, and a negative 11. Now that I've put everything where it belongs, I'm going to do some adding and subtracting. So negative 10 plus 2 is negative 8 x to the second. 4 minus 7 is negative 3 x's. And negative 3 minus 11 is negative 14. So we do the same exact thing we did in the other problems. The only difference is when there's a minus sign, we have to distribute it. It means the opposite of. So we have to flip all of these signs over here. So again, this negative means the opposite of. So the opposite of a negative 3x squared, positive 3x squared. The opposite of 7x is negative 7x. And the opposite of a plus 1 is a minus 1. So now I don't have to deal with any of this stuff. I've already changed it. It's written down below. So let's take a look. I have x to the second is my largest category. So I'm going to do x to the seconds, x to the firsts, and regular numbers. So I have, remember, I can't forget about this group up here. So I have negative 15 x to the seconds. So I'm going to put a negative 15. I have negative 4 x's. I have positive 3 x to the seconds, negative 7 x's, and a negative 1. So I've taken all my numbers. I had 5 terms. 1, 2, 3, 4, 5. And I have 5 numbers in my chart. So I didn't miss anybody. And now we're just going to combine these. So negative 15 plus 3 is a negative 12, and that's an x to the second. Negative 4 minus 7 is negative 11, and that's an x. And then negative 1 didn't get changed by anybody. So it's a little bit of writing, but these are very, very, very doable. So remember, the most important thing we're looking for, if it's a plus sign, you don't have to change anything. You just throw them in your little chart and figure out what your answer is. If you have a minus sign, if we're subtracting the group, then you have to do the opposite for the second group. That's the only difference, okay?